Hello and welcome to Automator's Edge. The quest for space colonization is underway, and I'm excited to share a compelling new development in that pursuit with you. But first, please zap that like and subscribe button. It's time to explore the world of control automation. The colonization of space will be an endeavor fraught with danger. But we're a curious species, and the urge for exploration is in part what makes us human. A major milestone in making planet colonization a reality happened recently as AddUp, an OEM specializing in metal additive manufacturing, has collaborated with Airbus Defence and Space to supply the European Space Agency with the first metal 3D printer for use in orbit. The partnership aims to usher in a new era of space exploration by enabling the direct manufacturing of critical space components in space. The metal 3D printer was launched aboard the Cygnus NG-20 resupply mission in January 2024 and installed on the International Space Station after extensive research and optimization for microgravity conditions. This collaboration between AddUp and Airbus signifies a major step towards in-space manufacturing, potentially reducing the reliance on transporting spare parts from Earth, which can take up to 12 months. Would you like to live on another planet? Well, before blasting off, stay tuned for our premiere product highlight, sponsored by Mouser Electronics. The Omron F440 FC mount smart camera is a high-performance imaging solution featuring a 5MP monochrome global shutter sensor with a rapid 35 FPS image acquisition rate. It offers enhanced frame rates through pixel binning and region of interest modes, ensuring versatility in various applications. Compatible with C-mount lenses and external lighting, this compact camera boasts the smallest footprint in its class and an IP40 rating for durability. Equipped with advanced vision tools and robust communication support, the Omron F440 FC mount smart camera offers unparalleled functionality for industrial imaging needs. To learn more, visit Mouser.com today. As Carl Sagan once said, the brain is like a muscle. When we use it, we feel very good. In this spirit, we bring you David's Corner.
Thanks, Andy. Understanding how fast your motor is actually rotating is a really important task, and usually we rely on this device attached to a motor that's called an encoder. An encoder is able to measure through light and dark transitions how fast the motor is rotating. But what does it actually look like inside? And how does it work? Inside an encoder, there is a light sensor with an LED that shines through a very small disc. That disc has a whole pattern of light and dark marks around it, and as the discs of light and dark transitions pass through the light sensor, it's able to count the number of intervals. And what's amazing is how many intervals they can fit on some of these discs. We can see encoders that have up to 1,000,000 points per revolution, an astounding amount of precision and reliability to accurately know exactly how fast and where your motor is rotating. When we put these motor and encoder systems together, we'll often refer to that as a servo mechanism or a servo motor because it contains both the motor output and the feedback. But it's impressive to see the precision and the manufacturing of both the disc as well as the sensing elements that are used to be able to precisely measure each one of those transitions, along with indexing marks that can tell it where it is in its current rotation, in addition to how fast it's going. Modern control systems require very precise attention to detail in motion, so that's why it's not sufficient to simply rely on old technology that only gives us a few points per revolution. We have to rely on modern manufacturing to get us some of the most impressive devices out on the market. Andy?
That's all the time we have. Hey, don't miss out on our virtual control automation days on March 26th. It's going to be filled with industry insight, education, and fun giveaways. Head over to control.com now to register, and we'll see you there.